Good evening, everyone. In our previous lecture, we have studied about the network elements. That was network elements we have studied, and this we have studied what is linear circuit, linear, non-linear, and we have studied what is active element, active source, or passive element, what we call it unilateral and bilateral elements, and we have studied lumped parameters and distributed. Then we have studied about the resistance, and with that we have studied about the different sources, that was AC and DC. In DC we have defined two things, that was dependent and independent voltage or current. Then we have studied what is ideal case and what is practical case. In this practical case we said that if it is a voltage, this is ideal case, the voltage remains the same, but due to the internal resistance, that is Ri, the graph goes down. These are the due to the losses. This is the internal resistance. This was the practical case, and we have gone through some of what is node, what is junction, what was the third was what is branch, what is loop, and fifth we have studied what is mesh. We have studied till now. Now moving forward, we have some of the source transformation. This source transformation, these now what we are going to understand, these are the tools to solve the big network or complicated network. So the first thing that we will be understanding is what is source transformation. In simple, we can say that the source transformation means we are going to convert the voltage source can be transformed into the current source, and the current source can be transformed into the voltage source. So if we see the figure number 1 and figure number 2, if we see this figure, what we are going to see, this is the active source, that is in the terms of the voltage. We have Ri, this is known as internal resistance, and we have RL, this is known as the load resistance, and we have IL, that is load current, and we have VL, this is the voltage across the load resistance. So in the figure 1 and the figure 2 we can see, let me erase this. For example, if I take one example like this, we have Vs value of something like 10 volt, and we take Ri, internal resistance, as 5 ohm, and load resistance RL is equal to RL. We are not going to change the load resistance. We are just transforming this part to this part. That means voltage to the current. So if we see that, then we know that Ohm's law, according to the Ohm's law, we said that the voltage is equal to the resistance into this. So I can be calculated I is equal to V by R. So if I V is 10 and R is 5 ohm, then we have 2 ampere as the current. So when we are transforming to the voltage to the current source, IS value in this case will be the 2 ampere and Ri remains the same, that we have said the IR is 5 ohm, and RL remains the same, VL is equal to remain the same, and we need to calculate the value of IL. This is required. In the second case, if we transforming the current to the voltage source, that we are transforming the I to V, we want to make it voltage source, then what will happen? We know that these two are in 2 ampere into 5 ohm, that will transform into give me the voltage that is 10 volt. So the 10 volt, the Vs value will be 10 volt again, and Ri is the internal resistance that was 5 ohm, that we know that. So we have transformed the voltage to the current and then we current to the voltage. So what is the difference? If we see the voltage to the current transformer, the current is going to be the Ri comes out to be in the parallel with the Is, whereas if we transform the current to the voltage source, we can see that the Ri is coming in the series. That you have to remember when we are going to for the source transformation. So I need to calculate the value of IL across this. So how we are going to calculate from figure 1, if I need to calculate the value of IL, it will be calculated as Vs upon Ri plus RL. This is the total load current. And if from the figure 2, if I need to calculate the value of IL, then I need to find out this. We can see this here. That is, we have taken this. IL will be equal to the total current that is flowing to the circuit. For example, if we say that this was the total current, will be something like this. The I will be equal to the I into Ri into Ri into RL. This is a source transformation. Coming to the other tools, that is KCL and the KVL. We have the two laws, that is KCL and KVL. In the short, we say that the summation mathematical, if we go for the mathematical then if we say n is equal to 1 and it is going to the till k, then v of n is equal to 0, and again we can say for n is equal to 1 it is going from till k, then in will be equal to 0. What does it mean? That means sum of all the voltages, sum of all the voltage will be equal to 0. That means, and in the KCL we can say sum of all current flowing the circuit will be equal to 0. So in this we can say this is the KVL equation we have taken, and this was the circuit that it was having that is having the V volt, and this was the due to the RI1 we can say, this is RI2 we can say, and this is RI3 we can say this. So this will be the I will be the current, because in the series the current remains the same, but the voltages due to this will be the V1, V2 and V3. So that means the sum of minus V, if we are starting from this point, we are taking minus V and it is going inside, then plus V, plus plus, and this will be equal to 0. If I start from this point, we can use this equation 1, and if I can write it in the terms of v1 plus v2 plus v3 is equal to v. We can say that also. So this is the sign convention that we need done. So this means that the sum of all the voltages will be equal to 0. So v is this. The KVL is independent of the nature of the element. Now coming forward, what is KCL equation? If we go for the KCL equation, we can say that this is the point. We can say junction as we studied earlier, and it means all the current that is coming or outgoing. Incoming current, we can say that incoming current is equal to the outgoing current. We can say this. So the incoming current was I1 plus I2, and outgoing current we have taken I3 plus I4. That we can write it like this: if I1 plus I2 minus of I3 plus I minus I4 will be equal to 0. That means the current meeting at a junction will be equal to the incoming current will be equal to the outgoing current. So this is how we represent it. It's stated in a circuit node at any instant the algebraic sum of the current flowing toward the junction will be equal to 0. So this is according to the law of conservation, the net charge at the node is 0. What was the node? Node we have defined earlier also. Two or three branches meeting at a point, or node, two or more three branches, or we can say the best way to understand that the node is that the current distribution will take place. This will be the node, this can be the branch, this will be R1, this is going to be R2, and this will be R3. So at this point more than two branches are meeting with a which is having some element in it, so we can say the incoming current is will be equal to the outgoing current. So in this we have this. We are saying the KCL is independent of the nature of the element, and alternative form of the KCL, the sum of the current entering the node is equal to the sum of the leaving current the node. That is that we said I1 plus I2 will be equal to I3 plus